Hi, this is Thomas. Welcome back. Our topic is binomial expansion, and now we're looking at example number 3. Our binomial term is 1 over quantity 2 plus 3x to the power of 2. Our requirements: find the binomial expansion up to and including the term x to the power of 3. 2. State the range of values of x for which the expansion is valid. This example is slightly different than the first two examples we've seen. First, let's begin with step 1, identify n term and x term. Let's begin with some manipulation of the binomial. 1 over 2 plus 3x squared is the same as 2 plus 3x to the power of negative 2. Now, notice in the binomial expansion that we're using in the upper right corner of the screen, we want to start with a constant term of 1 in the binomial. As it stands, we have a constant term of 2. So we're going to divide each of our terms by 2. We have a binomial expression, which is all to the power of negative 2. And what I'm going to do is some manipulation. I'll have the first term 2 divided by 2, the second term 3 divided by 2x. In order to offset divide by 2, I'm going to multiply the entire binomial by 2. So I've divided each individual term by 2. I'm multiplying the entire expression by 2 as an offset. Now, the reason for that manipulation is I want to get my first term to be 1, and that is going to be the case now. So in the next step, I'm going to simplify and distribute the exponent of negative 2. I have 2 to the power of negative 2 times 2 divided by 2 is 1 plus 3 over 2x to the power of negative 2. And now the binomial is in a format in which we can apply our binomial expansion. Now we'll identify the n term and the x term. Our n term is negative 2, and our x term is 3 over 2x. With those terms, we can go to step 2, substitute in n term and x term. Recall that the entire expression is going to be multiplied by 2 to the power of negative 2, which simplifies to 1 over 4. And now inputting the terms into the binomial expansion, we have the first term of 1 plus n times x, which is negative 2 times 3 over 2x, plus the following term, denominator of 2 factorial. Numerator is n times n minus 1, which is negative 2 times negative 2 minus 1, all multiplied by the x term to the power of 2, 3 over 2, x to the power of 2, plus our final term with a denominator of 3 factorial, the numerator of n times n minus 1 times n minus 2, negative 2, times negative 2 minus 1, times negative 2 minus 2, multiplied by the x term to the power of 3, which is 3 over 2x cubed. Close brackets. We've completed step 2 as well as step 3, going out to the required term. Now step 4, simplify terms. So we have 1/4 times the first term of 1, second term negative 2 times 3 over 2x, which will give us negative 3x. The following term in the numerator, negative 2 times negative 2 minus 1, which will be negative 2 times negative 3, or positive 6, over 2 factorial, which is 2 times 1, 2, times quantity 3 over 2 times x to the power of 2. So 3 over 2 squared will be times 9 over 4 times x squared. our following term in the numerator. Negative 2 times negative 2 minus 1 times negative 2 minus 2 gives us negative 2 times negative 3 times negative 4, which is minus 24, over 3 factorial, 3 times 2 times 1 is 6, times quantity 3 over 2x to the power of 3 is 3 to the power of 3, 27, over 2 to the power of 3, 8, times x to the power of 3. Close brackets. Continuing to simplify, 1 over 4, brackets, 1 minus 3x plus 6 over 2 times 9 over 4. 6 over 2 simplifies to 3. 3 times 9 is 27 over 4 times x squared, minus 24 over 6 is 4. And notice that we have a 4 multiplied by 27 over 8. So 4 over 8 is 1 over 2. 27 over 2, x to the power of 3, close brackets. And finally, I'll distribute 1 over 4 to all 4 of the terms of my expansion. So 1 over 4 times 1 is 1 over 4, minus 3x times 1 over 4 is 3 over 4x, plus 27 over 4x squared divided by 4 is plus 27 over 16 x squared, minus 27 over 2 times 1 over 4 is minus 27 over 8 times x to the power of 3. And finally, I'll add my notation to show that while we have expanded to the x to the power of 3 term, the series is infinite. On to step 5. Evaluate interval of validity as absolute value of x term is less than 1. Note that this is our requirement number 2. So the absolute value of our x term less than 1, our x term is 3 over 2x. This simplifies to the absolute value of x is less than 2 over 3, or negative 2 over 3 is less than x is less than 2 over 3. We've completed both of our requirements. This concludes binomial expansion example 3.